Jai Hind all of you. I'm Dr. Rahul Bansal from Ajay Kumar Garg Engineering College, Ghaziabad. So this one is the next video lecture for the electron devices KEC 301. So let us start. So in this video lecture, we will be discussing about the different operation of the transistor, right? So in the previous video lecture, we had discussed about the transistor constructions, right? How do we identify the transistor, whether it is PNP or NPN transistor, right? So in that video, we had discussed that is like your emitter side and collector side will be like having the same like if I made this as like P type of semiconductor, it will be having like P, this emitter will be a P type semiconductor, right? So this PNP transistor, right, this arrow will be inside of this, and for the NPN transistor, this arrow will be in the outward direction, right? So this is how we identify the PNP transistor and the NPN transistor, right? So next is operation of a transistor in the active mode. So in the active mode, we had discussed in the previous video lecture, that is this emitter base junction. If I say this junction is emitter base junction, right? So emitter base junction is forward bias, and collector base junction, that is JC, is reverse bias. So this is the condition that is to be satisfied for the transistor to be working in the active mode, right? So under this condition, this transistor is working in the active mode, right? So this P side, if I consider the PNP transistor, this P side is to be connected to the positive terminal of the battery to make this as forward biasing, this JES forward biasing. Now to make JC, that is collector base junction, at the reverse biasing, this P side has to be connected to the negative terminal of the battery, and this N side is to be connected to the, this base is to be connected to the positive terminal of the battery. So this junction is said to be reverse bias, right? Under this condition, this transistor can be called as, working in the this active mode, right? So this emitter will provide the majority charge carriers. So corresponding current is IE, that is the emitter current, right? This emitter current will be further divided into this collector current and base current, right? So we can write the generalized equation for this, and this equation will be valid for the PNP as well as NPN transistor, right? So what is the equation? Equation is like IE is equal to IC plus IB, right? So this is the generalized equation which is valid for both the type of transistors, right? Now in this case also, this IE is equal to IC plus IB. Now if you see, this IC is also the combination of two currents, minority charge carrier current and majority charge carrier current, right? So this is also the kind of two type of current, right? Now majority charge carrier current is also called as the diffusion current, right? So diffusion current is due to the majority charge carriers. Now minority charge carrier current is due to the like minority charge carriers, and it is also called as the drift current, right? So this IC is equal to drift current plus diffusion current, right? So if I define the drift current, it is actually due to the minority charge carriers, right? And this minority charge carriers are actually temperature dependent parameter, right? If at all temperature is varied, this minority charge carrier current will also varied. So we should take care of this, right? For any device to be working as the ideal case, this minority charge carrier current should be as minimal as possible, right? So this drift current it is like represented as ICO, right? And diffusion current, that is alpha IE, right? So this alpha IE means this alpha is actually the ratio of the current, right? It's actually the factor, constant value, right, which is assigned, which depends on how much charge carriers are recombined at the base, right? So its value, this alpha value, lies in between like 0 to 1. Typical value is 0.9. Typical value is 0.9, right? So this alpha value will decide that how much is the recombination at the base. This is also a crucial part in case of this BJT, right? Now, common base configuration. Now first we have to discuss that how do we decide whether it is common base or whether it is common emitter or whether it is common collector. So based on the input, output and common side, we divide the transistor into 3 different categories, right? So let me explain to you in this blank slide, that is configuration, right? Input, output and common side. So I will tell you the simplest method to decide whether where we have to give the input for corresponding configuration, right? So if I say like first one is like common emitter, common base, second one is common base, third one is common collector, right? So for the common emitter, as the name signifies, common emitter, it means that emitter will be common, right? So common side will be emitter, right? Now we must learn one thing, that is, if at all the side is common, right, it cannot be used as the input and output, obviously, right? And for the common emitter, this emitter is common, it cannot be input or output. Input will be given at the base side and output will be taken from the collector side. Now for the common base, common side will be base, input will be given at the, now input will not be given at the base side because it is already common, right? So input will be given at the emitter side and output will be taken from the collector side. Now for the common collector, right, input will be given at the, for the common collector, input, common side will be collector, input will be given at the base side and output is taken from the emitter. So these are the different type of configurations that we use, right? Now if I take the case that is common base configuration, right? So common base configuration, it means that base side will be common and input will be given at the emitter side, right? One more concept that I want to discuss is, that is H parameter model. that I will discuss in the in the next class, in the next video lecture, right? So this common side is base side. Input is given at the this emitter and output is taken from the collector, right? In the simple way, this is in the simple way, how I can represent is, this is your BJT, right? So this is your input side, that is I1, and input voltage is like V1, output voltage is V2, current is I2. So this is the common thing that we have, right? Now from this diagram also you can just notice that IE is equal to IC plus IB, that we have discussed in the previous slide, right? Okay. So for the common base configuration, if I want to plot the input characteristics, right? So first we should know what is the input voltage and what is the input current for the common base, right? So this is your common base, right? And what is the parameter that is to be kept constant? So for that we should know about the H parameter model, right? So what does it say? H parameter model, V1 equal to H11 I1 plus H12 V2, I2 equal to H21 I1 plus H22 V2. Now if you see carefully, input characteristics for the device. So this is your BJT, if you see, and it's your input port. It consists of two port, input port as well as output port. So this one is like input current and input voltage is like V1, output voltage is V2, and output current is I2 and voltage is V2, right? So this is your input and output for the BJT, right? And this is your H parameter model. So input characteristics will be in between V1 and I1 while keeping this V2 as constant. Output voltage is to be kept constant if we want to plot the input characteristics of any configuration. It is in between the V1 and the I1, keeping output voltage constant. Now if I talk about the output characteristics, it is in between I2 and V2, and the parameter which is to be kept constant is I1. I1 is to be kept constant if we want to plot the output characteristics of any configuration, right? So before we discuss about the another this common base configuration of common emitter configuration, we must know about the early effect also, right? So take the common base configuration, simple common base configuration, right? And if it is working in the active mode, right? So if it is working in the active mode, it means that this emitter base junction is forward bias and collector base junction is reverse bias, right? So this is your like JC, JE, and this is your JC, right? So two junctions are there, right? So emitter base junction is JC is reverse bias, JE is forward bias. Right. So JC is reverse bias. So if we, so why it is reverse bias? This N is connected to the positive terminal of the battery. Right. And this P is connected to the negative terminal of the battery. Right. So now if we further increase the reverse biasing, if we further increase this voltage, then there is a huge difference between the doping concentration of this collector and this base. Collector side is having more doping than this base, right? Such that if we increase the reverse biasing voltage, then this depletion layer will be penetrate more into this base region, right? So this depletion layer will penetrate more into this base region, right? Such that this base width, effective base width will reduce, right? So this effective base width will reduce. Correspondingly, there will be many changes in the circuit, or you can say many changes in the parameters value, right? So this effect is called as the early effect, right? So due to the change in the voltage, reverse bias voltage, base width has been modulated. That's why it is called as the base width modulation, right? So this is called as the base width modulation, right? And if we further increase this voltage, reverse bias voltage, then a point will come when this base width will completely disappear. At that point, your transistor is damaged, right? This is said to be punch through and reach through, or reach through. This condition is said to be reach through or punch through, right? So under this condition, transistor will be damaged completely, right? So this effect is called as the early effect. You can just write here, early effect. So what is the effect of early effect? What are the changes of due to this early effect in the circuit, right? First change is IE increases, right? Your emitter current will increase drastically, right? A point will come when this emitter current will be large, such that it may lead to damage of this transistor, right? Next effect is beta value increases. Although this high beta value is beneficial, but this high beta value should be during the manufacturing only. If it is increasing due to the change in the parameter value, then it is not beneficial, right? This is called as the this will cause the instability in the circuit, right? So beta value increases and IE, that is emitter current, increases, and third is punch through. So these are the three major effects of this early effect. So thank you all of you, right? And in the next video lecture, we will be discussing about the input and output characteristics of common base, common emitter amplifier. Thank you.